So, unless you took pre-cal, this is probably brand new material for you. Because I don't think that in high school algebra, even in algebra 2, that you learned this. So, um, here we go. Just as a reminder, and we've been I've been showing you this basically since chapter 2. When it says y equals, that's equation notation. That's the same thing as f of x equals. So f of x is called functional notation. Why? Because it's so much quicker and easier to say find f of 2. Saying find f of 2 is the same as saying when x equals 2, what is the value of y? So it's just a shorthand way of doing it. Note, when given a function and told to find g of 1, replace all x's with 1 and work the math problem. In other words, put it in Mr. Goodbuddy calculator or put it in Desmos. And I'm going to show you an example of one of those in just a moment. Now, when given a polynomial fraction, which is also called a rational equation, to graph, when you're using your calculator, use parentheses around the numerator and around the denominator if there's more than one item in either one. Now, you can, when you're using Desmos, you can also just use the fraction key, which is with the question mark key. It's the /. Anyways, note, for rational equations, the domain is restricted. Domain is restricted where the denominator equals 0, because you're not allowed to divide by 0 until you get to calculus. Now, also, at that x value, there is a vertical asymptote that I shortcut to VA. There are two cases for the horizontal asymptote, HA. All right. Case 1. The degree in the denominator is bigger than the degree in the numerator. I can't spell today. In this case, the horizontal asymptote is y equals 0. Case 2. The degree, when I say in the denominator, I mean in the bottom of the fraction. The denominator equals the degree in the numerator. In that case, the horizontal asymptote is y equals the division of leading coefficients. And I'm going to coefs, okay, coefficients. And you'll see how to deal with both of these. And and you don't have to divide the x's. All you have to do is divide the numbers. So number 1, which is actually, I think, number 2 in your homework, is 1 over x minus 4. So I'm going to Desmos with this. I'm going to hit the fraction key or the /. 1, then arrow down, x minus 4. All right. Now, on this one, I don't have to graph it. All I have to do is type in specific values. But I wanted that equation there. Now, I'm going to start with one of the biggest values, 1.0001, and that value is 10,000. And then I go back and I kill one of the zeros. So that's 1,000. I kill another 0, and that's 100. And I kill the last 0, and that's 10. Then I get 3.9999. That's negative 10,000. Kill one of the zeros, negative 1,000. Kill another 0, negative 100. Kill another 0, negative 10. Now, I go back to my, I went a little bit far. Okay, I went a little bit far. Okay, on here. This was negative 10, negative 100, negative 1,000. This was positive 10, positive 100, and positive 1,000. Now, I'm going to graph it here instead of going back to Desmos. 2, 3. Takes me a little bit to graph, and I have trouble breathing while I'm trying to graph. So, it looked kind of like that. So your domain was everything except 4. Negative infinity all the way up to 4. And because it has another part, you have to have the happy face. 4 to infinity. Your vertical asymptote is at x equals 4. Now, the degree in the top is 0 because all you have is a constant in the top. the degree in the bottom is a 1. So the degree in the denominator is bigger than the degree in the numerator. So your horizontal asymptote is y equals 0. Now, if you look around here, as x approaches from the right, here's the right. I'm coming at it from the right. This is going up. So that's going to positive infinity. As I go at it from the left, I'm getting a phone call. Probably a spam call. As I go at it from the left, it's going down. Down is negative infinity. Okay. Now, here we have to graph it first. And let me write it down. Negative x squared plus 9. Negative 2x squared plus 32. All right. Hit the fraction key first. Negative x, shift 6, 2, plus 9, go down. Negative 2x, shift 6, 2, plus 32. Ew. Notice this right here is, I want to do something. Y equals 1. Okay. Well, it's getting close. 1 is halfway between the 2 and the 0. So let's put 1/2 here. Do you see how this is hugging those blue lines up at the top here? Negative 1 divided by negative 2 is positive 1/2. All right. Now, also notice if I put in x equals negative 4, see that purple line is hugging the blue lines. Now if I put that as positive 4, it's also hugging the blue lines on the other side. So that was a whole lot of information. All right. Now let me go back into this. All right. Like I said, that was a lot of information. So we can't have, we've got vertical asymptotes at -4 and +4. And we've got a horizontal at +1/2 or 0.5. Yikes. Now, the domain we got to be a little tricky with. -infinity up to -4. And we've got two more pieces. -4 to +4. This one's ugly. And then 4 to infinity. Because that one was gross. Okay. Let me kind of show it this way. It was like this. So there were 3 unique pieces. Therefore, I have to have 3 intervals. And these cutoffs at -4 and +4 are the cutoffs in the middle, right here. Find the domain and the vertical and horizontal asymptotes. Separate your asymptote answers with commas. Did it say separate? Oh, it did say separate your answers with commas. I did not catch that before. I lied. Instead of happy faces, put commas. Some programs say put happy faces, some say commas. Sorry about that. Now, I guess I should read my own instructions. Okay, so let's go into Desmos. Let me write this problem down. 3x squared, x minus 4. I should have printed this off first. Fraction key, 3x squared, and then x minus 4. Whoops. Go down. X minus 4. Ooh, that's weird. Scroll out until you see other stuff. Hey, we don't have a horizontal. Something new happened here. And I'm going to call this y equals x. Nope. Y equals, let's say, 3x. I think that's right. Something like that. Y equals 3x. plus 1, nope, plus 3, nope, plus 4,